Have you ever looked up at the night sky and wondered where everything came from? Not just the stars and planets, but everything right here on Earth. Think about the chair you are sitting on, the phone in your hand, or even the air you breathe. Where did the atoms that make up these things originate? The answer is not found on our planet, nor in our solar system. It is a story that begins billions of years ago in the fiery hearts of giant stars. These stars lived spectacular lives and died in even more spectacular explosions. We call these explosions supernovae, and they are the universe's ultimate creative force, forging the very elements that make life possible. Imagine an explosion so powerful it can outshine an entire galaxy. An entire galaxy contains hundreds of billions of stars, and for a short time, a single supernova can be brighter than all of them combined. This is not science fiction. This is the reality of a supernova. It is the final, breathtaking act of a massive star's life. These cosmic fireworks are more than just a pretty light show. They are the engines of creation in our universe. To truly understand a supernova, we must first understand the life of a star. Let's imagine a journey into the heart of a truly massive star, one many times bigger and brighter than our own sun. From the outside, it appears as a brilliant, searing ball of light. But deep within its core is a factory of cosmic proportions. Here, the temperature and pressure are so extreme that they defy everyday comprehension. We are talking about millions of degrees and pressures that are billions of times greater than what we experience on Earth. Our journey begins not with a bang, but with a quiet gathering. It starts inside vast cold clouds of gas and dust that drift between the stars. These are called molecular clouds, or more poetically, stellar nurseries. They are some of the largest objects in our galaxy, stretching for hundreds of light years across the cosmos. From a distance, they might look like dark patches against the starry backdrop, obscuring the light from behind. But inside these dark clouds, the seeds of new stars are slowly taking shape. These nurseries are mostly made of hydrogen, the simplest and most abundant element in the universe. But they are also sprinkled with tiny amounts of dust and other elements left behind by previous generations of stars. The protostar keeps growing, pulling in more and more gas and dust from its parent cloud. Its core gets hotter and denser with each passing moment, and the pressure building up at its center is, honestly, almost unimaginable. Finally, a critical point is reached. The temperature in the core soars to about 15 million degrees Celsius. At this incredible temperature, something magical happens. The hydrogen atoms, which have been squeezed together so tightly, begin to fuse. They slam into each other with such force that they merge to form a new, heavier element, helium. Let's follow the life of one of these cosmic giants. For a few million years it shines brilliantly, a dominant force in its stellar neighborhood. Its immense gravity and luminosity have a profound effect on its surroundings, carving out a huge bubble in the interstellar gas around it and pushing away the very material from which it was born. But deep in its core, the clock is ticking. The star is burning through its vast reserves of hydrogen fuel at an astonishing pace, and sooner or later that fuel is going to run out. When the hydrogen in the core is exhausted, the fusion furnace flickers and dies. The outward pressure that was supporting the star's immense weight suddenly vanishes. Throughout its life, the massive star exists in a state of delicate balance. It's a constant tug-of-war between two of the most powerful forces in nature. On one side, you have gravity, the relentless force that pulls everything together. The star's own immense mass is constantly trying to crush it down into the smallest possible space. On the other side, you have the force of creation, nuclear fusion. Deep within the star's core, the extreme heat and pressure create a natural nuclear reactor. This reactor fuses lighter elements into heavier ones, and in doing so, it releases a tremendous amount of energy in the form of light and heat. This energy creates an outward pressure, a powerful thermal radiation that pushes against gravity's inward crush. The star has reached the end of its long and brilliant life. Deep within its heart, a core of iron has formed. But, this is not the strong, sturdy iron we know on Earth. Instead, it's a super dense ball of iron atoms, packed together at temperatures of billions of degrees. Iron is different. Iron is the ultimate cosmic ash. Fusing iron atoms together into something heavier actually requires energy. It doesn't release it. The star's energy source has been extinguished. With the nuclear furnace in the core now cold, the outward pressure vanishes in an instant. The inward falling material from the star's outer core slams into the newly formed, ultra-dense neutron core. Imagine, if you will, a speeding freight train hitting a solid steel wall. The collision is so violent that the collapsing material doesn't just stop. It bounces. This rebound creates a powerful shockwave, a titanic blast wave of energy that begins to move outwards. This is the beginning of the supernova explosion. The answer came from the tiniest, most elusive particles imaginable, neutrinos. In that critical moment, just a tiny fraction of these neutrinos slam into the material behind the shockwave, depositing their immense energy into it. Reinvigorated by the flood of neutrino energy, the shockwave is now an unstoppable force. It resumes its violent journey out of the star's core and into the surrounding layers. As the shockwave rips through the star's onion-like shells, it compresses and heats them to incredible temperatures. This triggers a final explosive wave of nuclear fusion. The shockwave continues its rampage, accelerating the star's outer layers to fantastic speeds. We're talking about speeds of up to 30,000 kilometers per second, or 10% of the speed of light. Finally, after a journey that may have taken hours, the shockwave reaches the star's surface. This is the moment a supernova becomes visible to the rest of the universe. The supernova explosion is more than just a destructive event. It is the universe's ultimate furnace. In the fiery chaos of the exploding star, conditions are created that just can't be replicated anywhere else in the cosmos. For its entire life, the star was a patient alchemist, slowly turning hydrogen into helium, and then into heavier elements all the way up to iron. To create the rest of the elements that make our world interesting and complex, a much more violent process was needed. That process is the supernova. Let's dive deeper into the specific process that creates these heavy elements. It is called the rapid neutron capture process, or the R process for short. An iron nucleus, for example, suddenly finds itself in the middle of a torrential storm of neutrons. It is bombarded from all sides by these particles. The iron nucleus captures a neutron, becoming a heavier isotope of iron. Before this unstable new nucleus has a chance to decay radioactively, it is hit by another neutron, and then another, and another. An iron nucleus that has absorbed a huge number of neutrons might, through a series of beta decays, become cobalt, then nickel, then copper, and so on, climbing up the periodic table to become elements like silver, tin, gold, mercury, lead, and even uranium. The explosion has happened. The star is gone, but its story is far from over. In its place is a vast, beautiful, and ever-expanding cloud of gas and dust. This cloud contains all the elements the star created during its long life, from hydrogen and helium in its outer layers to the carbon and oxygen from its core. This remnant is not a peaceful, static cloud. It is a turbulent, chaotic environment, still reeling from the force of the explosion. The remnant is effectively a delivery service, taking the precious materials made deep inside a star and distributing them far and wide across the galaxy. The death of one massive star is the starting point for the birth of countless others, and potentially for life itself. The atoms of gold, oxygen, carbon, and iron that were created in the star and its explosion are now mixed into these cosmic nurseries. Each generation of massive stars that lives and dies adds more heavy elements to the cosmic mix. The galaxy becomes progressively more polluted with these elements over billions of years. This is why older stars, which formed early in the universe's history, have very few heavy elements, while younger stars like our Sun are relatively rich in them. A new star ignites at the center of a collapsing clump of gas and dust. Surrounding this young star is a swirling, flattened disk of leftover material. This is a protoplanetary disk, and it contains the complete recipe for building new worlds. This disk is no longer the simple mixture of hydrogen and helium from the early universe. It is a cosmic stew, brimming with all the elements forged in the heart of our dead star. Within this spinning disk, tiny grains of dust, rich in these heavy elements, begin to stick together. Think of it like dust bunnies forming under your bed, but on a cosmic scale. This is how our own Earth was born, some 4.5 billion years ago. It was built from the recycled remains of one or more ancient supernovae that exploded in our galactic neighborhood long ago. The supernova's contribution goes far beyond just building the planet itself. It also provides the specific essential ingredients required for life to emerge. The vast majority of your body is made of just 4 elements: oxygen, carbon, hydrogen, and nitrogen. Hydrogen was formed in the Big Bang, but the other 3 crucial elements were manufactured in the hearts of stars and scattered by supernovae. Think of the calcium that gives your bones their strength and structure, allowing you to stand and move. That calcium was forged in the dying breaths of a massive star. Consider the iron in your blood, nestled within hemoglobin molecules, dutifully carrying oxygen from your lungs to every cell in your body. That iron was the final product of fusion in a star's core, the very element that triggered the supernova collapse. This brings us to a profound and beautiful realization. You are not just living on a world made of stardust. You, yourself, are stardust. Take a moment to look at your hand. The atoms that make up your skin, your bones, your muscles, and your blood were not created here on Earth. They have a much more ancient and spectacular origin story. A carbon atom that is now in your brain may have once been at the center of a star 100 times the size of our sun. An iron atom in your blood may have been part of the star's core just moments before it collapsed and exploded. You are a walking, talking, thinking collection of cosmic history. You are a direct physical connection to the most powerful events in the universe. Our cosmic journey has taken us from the quiet birth of stars in cold, dark clouds to their final cataclysmic explosions as supernovae. These grand explosions are the universe's way of recycling, of taking the simple ingredients from one star and seeding the galaxy with the materials needed for new stars, new planets, and new life. This story is written not in books, but in the very fabric of our reality. The iron that gives our blood its life-carrying ability, the calcium that forms our bones, and the carbon that is the backbone of our DNA, are all chapters in this cosmic tale. We have learned that the universe is not a static stage, but an ever-evolving ecosystem where the death of one generation provides the raw materials for the next. This incredible story of our stellar origins is not just a collection of fascinating facts to be memorized. It is an invitation. It is an invitation to remain curious, to keep asking questions, and to never lose your sense of wonder about the universe and your place within it. Science has given us this amazing gift, the ability to piece together our own origin story, to trace our lineage back to the fiery hearts of long-dead stars. So, let this story be a starting point for your own exploration. Go outside on a clear night and look up, find the constellations. Think about the stars you are seeing, not as distant abstract lights but as suns, some of which might one day go supernova themselves. This is your cosmic heritage. The universe did not just create a stage for you to live on. It created you from its own substance. You are stardust, animated by curiosity. The same atoms that once burned in a stellar furnace now form the brain that allows you to ponder that furnace. This is perhaps the most astonishing fact of all. The universe has, through you, become self-aware. So embrace that legacy. Stay curious, keep learning, and never forget that you are a child of the cosmos, forever connected to the grand and beautiful story of the stars.